talks about what COBOL really is. So COBOL, the name it stands for Common Business Oriented Language, which is not a very catchy name, but it does describe exactly what COBOL was invented for. It is not a general programming language. When we think about a general programming language today, we probably will think about Python or JavaScript or Java or C++ or C Sharp. And COBOL was not intended as a general programming language. It was intended specifically for business logic. In terms of the underlying implementation, COBOL is built for business transaction processing. And we are talking about a huge amount of data processed in a very efficient manner. You can also see from the slide that this is actually related to Grace Hopper's Flowmatic. For those of you who do not know who Grace Hopper is, she is interesting. So just do a Google search on Grace Hopper and you'll find out why it is really amazing that COBOL actually has ties to Rear Admiral Grace Hopper. COBOL is not owned by any organization. IBM does not own it. Micro Focus does not own it. It is an ISO standard. And in 2017, 43% of all the banking systems utilize COBOL, to power up their information systems. And that's, even though it is less than 50%, the rest of the 50% was probably split amongst a whole bunch of programming languages, which means COBOL makes up the bulk of all the banking systems. In 2017, somebody did a research and found that 200 million lines of code were in use in 2017, and I really doubt that number has changed much today. Moving on to the next slide. So why COBOL is COBOL, which is pretty much a continuation of the previous slide. The first thing is COBOL was engineered for efficiency. That really has to do with when COBOL was implemented, computing resources was really scarce. Those so-called mainframe computers, back in the 1960s, do not really have a whole lot of resources, not in terms of RAM, in terms of processing power, and not in terms of input-output devices. So COBOL was designed and engineered for efficiency from the get-go. It is a compiled programming language as opposed to an interpreted programming language, which means it compiles to code that can run with very, very high efficiency. And somebody might argue that C and C++ are also compiled. So how does that compare? So I'm going to get into compilers and optimization just a little bit here. In C and C++, the language statements are relatively simple, so it's harder for the compiler to find out exactly what the programmer wants to do. And that makes optimization a little bit harder. In COBOL, COBOL has a very rich language. It's a very rich language, which basically means the programmer can choose to be very specific about what he or she wants to do. And as a result, the compiler gets a lot more information in terms of optimization. COBOL is also time-proven. It is compiled and it has a quote-unquote static nature compared to some of the programming languages today. And that is really by design to minimize runtime issues. This kind of goes along with JCL, which we'll talk about in just a little bit. There are decades of applications of COBOL being in use in critical information systems. So we already know that COBOL is time-proven. There's also a very large tool set for testing, debugging, and deploying COBOL programs, just because it has been around for long enough for these tools to be developed. One thing about COBOL, which is something that I would mention probably a few times in today's presentation, is it is intentionally readable and auditable. In other words, when you read a COBOL program, it reads kind of like a storybook. It doesn't use a lot of special symbols, like in C and C++, they use a lot of phrases. They use the dot notation. They use the pointer notation, and so on. COBOL doesn't have much of that. It uses regular stuff, regular symbols that we all recognize. And this is intentional because financial institutions and government agencies often require external and also internal auditing, and the auditors are usually not developers. So they do not easily understand code that is written in more cryptic programming languages. COBOL is also interesting in how backward compatible it is. 2014 COBOL is backward compatible to COBOL 60. So that makes the upward migration path smooth for organizations who want to continue to use COBOL and try to integrate more complex programming language features into it. So moving on to the next slide. So this is for kind of dispelling, certain beliefs or certain opinions of COBOL. So the first thing people notice, especially because of the news, the media today, is COBOL was created in 1960. Well, maybe a little bit before that. I think the concept came along in 1959 and not quite 1960. So that is true. I mean, that there is no doubt that COBOL has been around for a long time, and that's one of the things that it's actually a strength of COBOL. Computer science itself is much older. Modern day computer science, which is based on Alan Turing's papers, was, basically it was around since 1936. The automata theory of Alan Turing it came about in 1936. The von Neumann architecture, which is common to almost every single computer today, was invented in 1945. So the bottom line is a programming language is not a fashion statement. If it works well, then it works. Okay, there's no reason to learn or use a new programming language because it is cool. Okay, we use programming languages because they work. So the second point is, some people believe that COBOL is the reason why the New Jersey unemployment insurance system has problems. Well, that really is not the case. So why do we have those problems? Why do people report that the web interface is not working or it drops in and out? Well, that's because there's a long chain to backend transaction processing. COBOL programs typically sit in the very, very far back end to do batch processing. So requests that come in on a daily basis typically get stored, somewhere else, and then at the end of the day or at a certain time of the day, COBOL programs will process those transactions in a batch mode. And I suspect the problem of the New Jersey unemployment insurance system was due to all the other links before data gets to the COBOL programs. There are web servers, there are databases of different kinds that will store the request after people submit the request through a web interface. And all of that stuff are much more susceptible to a load increase. And basically, if they're not designed for the kind of load, they can have problems. And then the third sub-point is the lack of COBOL developers. Now that definitely can lead to a delay to the update of the logic. Because if you cannot find someone who can understand a COBOL program and you want to update the rules or the amounts, related to unemployment insurance, well, that obviously is going to be an issue. Where do we find that line of code to say that we need to change the amount to this amount, or we change the qualifying logic to the new qualifying logic? That can definitely lead to a problem, which is a problem from the perspective of people who want to file a claim, but it is actually a good thing for people who want to learn to program in COBOL because it really indicates there is a demand out there. The third point is COBOL is not object-oriented. That is not true because COBOL 2014 actually does support object-oriented programming. However, most of the 200 million lines of code in 2017 are probably not object-oriented. That is because business logic usually does not benefit as much from object-oriented programming as graphical user interface, mobile, or HTML client-side applications. That really has to do with objects that get displayed on the screen, the organization and the underlying structure of those, the logic of display objects on the screen, on a mobile, or in HTML, that really, those led it themselves to object-oriented programming a whole lot more than business logic. And then the last point on this page is COBOL is verbose and it is procedural. That actually is also intentional because remember, COBOL programs are often audited by people who are not developers. Object-oriented programming is very, very good at abstraction. Functional programming languages are very cool when it comes to expressing interesting algorithms. But most auditors are not developers. They do not have a computer science degree. So when someone programs or write a program in object-oriented programming fashion or in a functional programming language, those programs become basically unreadable to auditors. Moving on to the next slide. And then there are some perceived obstacles of learning enterprise COBOL. Even if somebody says, well, I really want to learn COBOL, how do I do it? Well, it turns out there are a few perceived obstacles. The first one is you need to know the mainframe operating systems. And trust me, I really try to do that myself. And there are a lot of terms that you have to learn, a lot of acronyms that you have to learn, a lot of abbreviations that you have to learn to get into mainframe operating system. And this is even if you have a fairly functional Linux or Windows file system experience already. There's also JCL, Job Control Language, which looks really archaic, but it is like that for a reason. You have to learn what is a data set, which is kind of like a file. You can call a data set a file, but it really is not a file. Because in the data set, you can have other units inside it that are also like a file. But it is like that for a reason as well. In the past, if somebody wants to learn COBOL, they have to learn the text-based terminal user interface. And we'll talk about that in just a little bit. So things are not very easy. You cannot just point, click, and start programming. And then you also need a server. You need to have a mainframe server in order to learn enterprise COBOL, because you need to have connections to a system that supports all the underlying operations. And guess what? The COBOL syntax is really the least of the obstacles, or at least the least of the perceived obstacles of learning the enterprise COBOL as a programming language. So in the next slide, we are looking into, let's try to make that learning curve not as steep anymore. So what the Open Mainframe project has done is it integrates COBOL programming into Visual Studio Code. A lot of people use Visual Studio Code for all kinds of programming now. You can use it for C++ programming. You can use it for JavaScript programming. You can connect to a web server, to make code development seamless. You can have the code running on a server, but you can add it on a personal computer. So Visual Studio Code is very flexible. The Zoe Explorer is an extension to Visual Studio Code or VS Code. It is free. ZOpen Editor is a component that understands COBOL syntax. It is also free. And a project just got launched, and I think Sudarsana can share with us the link to the landing page at some point, or maybe even in today's presentation. It's a free learner mainframe account. You can request to have an account so you can start learning and running COBOL programs. And because it's using VS Code, it doesn't really matter what operating system you're using. You can be using Windows, Mac OS 10, or Linux as the operating system on your personal computer side, but they can all connect to a server in order to run the programs. There's also a starter text for beginning or transitioning developers. It is also available for free. And for anyone who wants to get really, really into the COBOL programming language, the reference manual is also free. So let's go ahead and check out how to get to the course content. So the first thing is to go to GitHub, which is github.com, and then use the search bar to look for COBOL programming course. You are probably going to find two entries. The first one, which is the one from Open Mainframe, is the one that you want to click on. There are two documents you can download once you get to that particular web page. One is a doc file, and the other one is a PDF file. So either one is fine. If you want to open the Word file because you want to insert your own comments, that's probably a suitable applications for that. So in that document, it is broken up into three major sections. These are not the exact names of the chapter. Some of these are changed a little bit for this presentation. The first one is it talks about how to install VS Code with Zoe and also ZOpen Editor. So it will have screenshots to guide you through the entire process to get the whole thing up and running. The second part is a little bit longer because it really talks about the syntax of COBOL programming as well as concepts in COBOL programming. It is broken up into, the first one is data division, which basically talks about what we understand as variables in other programming languages. Then it talks about file handling, which is the input part of file handling. How do you open a file or data set so that you can have the data to be processed? The third one talks about structured programming in COBOL, because COBOL is not like C and C++. The way you perform structured programming is a little bit different. And the syntax obviously is going to be different as well. The fourth section inside this part talks about file output, which is kind of the user interface output. How do you print out something, as the result of processing? Then it talks about control structures. What is a loop? How do you make a loop? What are conditional statements? How do you specify a condition? Then we have arithmetic operations, which kind of it seems really simple, but COBOL has a very rich syntax when it comes to arithmetic operations. And part of the reason why it has such a rich language for expressing arithmetic operations, it's also related back to compilers, because the rich syntax allows compilers to really optimize the underlying object code for implementing those operations. And then it has data representation, particularly how numbers and text data is represented. Then it talks about intrinsic functions, which is a library of functions that are already implemented so that people do not have to reinvent the wheel all the time. And then the last portion are the advanced topics. It talks about IDZ, or the IBM Developer for Z. It talks about ISPF, which is the terminal text user interface that I was talking about a little bit earlier. But a lot of organizations make use of that particular interface because it is reliable, it's time proven, and some programmers have been using it for 20, 30 years. So they are very comfortable with that particular interface. And then the very, very last chapter is also very important. It's about testing and deployment, which is a really important concept in any type of shop that deals with critical information systems. So moving on to the next slide is a sample screenshot of how what it looks like, inside VS Code when we make use of Zoe Explorer. It is completely GUI based. It's point and click. It basically makes a remote connection to a IBM Z mainframe, and it retrieves the data from the mainframe, but it presents it on VS Code using a very user-friendly GUI. So in this particular example, it was looking at a COBOL program. The next slide talks about, it shows how the OpenZ editor is fully aware of COBOL program structures. So in this particular case, I was screenshotting how it can find out what's division of where each division is in a program. So this makes navigation a whole lot faster because you don't have to scroll all the way and you'll use your eyes to glance for a particular division. You can just use this drop down and say, I want to go to the procedure division to look at my code. It's really quick and easy. And then the next slide talks about how you get assistance from OpenZ editor. If you just type a part of the beginning of a statement, OpenZ editor will give you suggestions, just like any modern IDE or integrated development environment. OpenZ editor as an extension allows VS Code to do this. This is really kind of important because COBOL is a very rich programming language. That means there are a lot of ways to express statements. And it is not easy for a learner to learn it really quickly because in C and C++, there's only one assignment statement. Okay, if you count compound assignment statements, there are a few more, but nonetheless, the amount is limited. COBOL has a lot more statements related to just assignment. How do you change a variable? So it's really hard for someone to memorize all of that stuff when you're just starting to learn the programming language. Having this kind of assistance from OpenZ editor helps a lot. And then the next slide talks about edit time validation, which is pretty much what most people expect now from an IDE. So if I try to make use of a variable counter, like in this case, that does not exist, I don't have to compile the program. I don't have to submit the job. I don't have to run the program because the OpenZ editor itself is aware of the syntax and also the semantics of names in a program. So it can basically not only perform a syntax or grammar check on the program, but it actually tries to find out, hey, you're trying to use a variable here. Is it already defined? Well, as it turns out, this one is not defined. So that's why, when I just hover the pointer over the squiggly line, it already pops up a message to explain why it is underlined in red. And, there's no quick fixes in this case because, I actually have to define the variable first. So it's not something that the tool can automatically handle for me. On to the next slide, we talk about, how to run a job. Now, most people, who are used to an IDE or an integrated development environment would expect a green button to run the program. Zoe doesn't do it, okay? And that's because in mainframe type of programming, the job controls everything. The program is one part of a job because the program has to know, where the input is coming from and where the output is going to. And the job is basically describing that. So that is why, with COBOL programs, you cannot just right click on a COBOL program and say, run this COBOL program. You have to run a job that is associated with the program. But Zoe makes it relatively easy because you just right click on the job and then you click submit job and it will run it. So the next slide talks about, how do you look at the output from a job? So you have to look for the output under the jobs tab and then look for the job output. Every job has its own ID, has its own number. And you have to look for that. And then under that, you have to look at sysout, which is kind of analogous to standard output, of what we modern, in modern terms is the standard output. So in this case, it's just a hello world program which prints to system output, and this is where you find it. It looks a little bit different compared to how you would run a C++ program or a JavaScript program. But Zoe really makes it a whole lot simpler than without Zoe. So let's move on to the next slide, some afterthoughts. Zoe and Open Editor are currently still in active development. So, you can expect more features to be coming in and bugs to be fixed. They're both open source projects. There's a continuing effort to make learning enterprise COBOL a little bit easier. Um, it's a very rich programming language, and it does require some understanding of the operating system itself and JCL. But there are definitely a lot of efforts to try to make that learning curve shallower. And the project that you have seen here is part of that effort. Applications of enterprise COBOL are really out there. The California state government has an apprentice program to try to encourage more people to learn how to program in COBOL because they know and they have anticipated for years that there will be a shortage of COBOL developers. The same thing applies to financial institutions. I attended one roundtable once, and basically, all the major IT shops in Sacramento, they all confess, we all try to get people from each other. We all try to, convince people to leave one company and start working for my company. They all confess because there's a shortage of people who can develop in COBOL. So that's kind of the conclusion of the afterthought. The next slide talks about COBOL versus, because people like to compare everything, including programming languages. So I compiled a table to talk briefly about how COBOL compares to other programming languages. So I'm going to just make it a little bit fast here because I don't want to turn this into another lecture in computer science. But each line has a purpose. The first line has to do with whether a programming language is compiled or not. Now, a programming language that is compiled typically will run faster. And as you can see here, C, C++ are compiled, and so is Enterprise COBOL. Python can be compiled as well, but usually when people use Python, it is usually not compiled. JavaScript, depending on the implementation, can be compiled to some kind of bytecode. Java is definitely compiled to bytecode first, but bytecode means there's a second, an intermediate step before the code actually runs, because you have to have a virtual machine of some kind to run the bytecode. So they're not as efficient as a fully compiled language. The second line or the second row talks about whether a programming language is strongly typed or not, which is a good thing and a bad thing. The good thing about a strongly typed programming language is the compiler can do a lot of checks to make sure that the program seems to be logical. Okay, things are matching. A programming language like JavaScript, which is not strongly typed, means that, well, until you run the program and until you exercise every single branch and every single way to run the program, you really do not know whether the program is written correctly or not, as opposed to C, C++, and COBOL, where the compiler can go through the analysis of the program, check all the types, and alert you or tell you that, hey, this type, the way you use this variable is not consistent with the type of the variable. It can warn you and give you an error way ahead of time, which is basically what the second point or the third point, static validation, is all about, is how much can the tool analyze the code to tell you that there's a potential problem here. C++ has static validation, so does COBOL. JavaScript, you can have some extensions and do some static validation. But the reason why people use JavaScript is because it does not use static validation, because it can work with, it's very flexible. The third line or the fourth row talks about open standard. All the mentioned programming languages here are open standard. In terms of ease of access, you can see the first 5 languages are all yes. But in terms of Enterprise COBOL, we can say yes now, thanks to this project. The next slide talks about pointers. If you don't understand what a pointer is because you have not a program in C or C++, well, just think of it as something that is both good and bad. When pointers can lead to certain types of algorithms being implemented very, very efficiently, but at the same time, it's also very dangerous, especially the way it's implemented in C and C++. And Enterprise COBOL does not support pointers like it is supported in C and C++, so it doesn't have the same problems that C and C++ can potentially have. A lot of Stack Overflow exploits is due to the abuse or the misuse of pointers. And if a programming language does not support pointers like that, they naturally cannot have Stack Overflow exploits, or at least it's not as easy. The next slide talks about references to objects. You can see it's kind of the flip side of pointers. All the programming languages are cross-platform, except for in Enterprise COBOL, even though the programming language itself is quote-unquote cross-platform, but it really only runs on Z architecture. And then the last row is kind of important too, because all of the other programming languages do not have native support to read and write data that is stored on a mainframe computer, but Enterprise COBOL is built for that. That is basically its main purpose in life.